Hello again, everyone. We will continue the concept of SVM to see a little bit more about SVM on Python. We explained about nonlinear SVM and we explained about two techniques. One of them was adding the polynomial features. Another was using RBF technique to add features and convert data set which is not linearly separable to the data set which is linearly separable. We want to see that how these techniques can be used on Python. Before starting, I would like again to recall you that we will use a Scikit package to implement our models. So we have explained before about the iris data set here in this Google Colab that has been posted on Carmen. But again, I will import this data set, and here we have this data frame for this data set. One more time, this data set consists of 150 rows, 150 flower, and we have information about these iris flowers for petal and sepal lengths and widths. Also, as we can see here, if we plot this data set on matplotlib, which is one package which can be used for plotting data set, then we will reach to something complicated. Here, as you can see, if we consider this data set and if we consider just the data set on two labels, then we will get these points that, as you can see, it is linearly separable and it can be done. But today I do not want to talk about iris dataset because in another video we talk about dataset, this dataset. Today I want to explain a little bit about how the process of RBF and the process of polynomial kernel can be done on Python. So again, we want to use the concept of pipeline very quickly. What pipeline is, if you want to do some lines of code in one package, you can use pipeline. Then here, as we explained, if we want to import pipeline, it can be found on Scikit-learn pipeline. Then I will import pipeline. Also, pre-processing, as we explained, for the pre-processing, sometimes we need to change the scale of the features. Then standard scaling is one of the very good technique which is used a lot in machine learning techniques. And if we want to do a standard scaling, then we need to call it from this sub-package, pre-processing. And if we want to do SVM again, SVM can be found on SVM, then linear SVC is the technique which is used here for SVM. So then here also, I want to import another technique, which is polynomial feature. So now, because we do not want to use linear SVM. In this case, we want to use the SVM on the non-linear data set, non-linearly separable data set. Then I will import from SVM SVC. Then see, if you want to use linear SVM, you will import linear SVC. But in this case, since I can see that my data set is not linearly separable, therefore, I need to use another type of SVM, means non-linear SVM, and in this case, we will import SVC. Okay, now we want to train a model on the data set, this data set X and Y that we define here, but the goal is to use this data set and train a model. One time we will use the polynomial feature, another time we will use the RBF. So then first we need to rescale our feature. Then standard scaling is the technique which is used. Then here, after defining this pipeline, in the first step, we will use the standard scaling. And after that, we have the model SVM. And here we are using SVC. Then see, because you want to use the polynomial feature, then here we have this kernel, and kernel is defined as poly. This poly should be written between quotation marks. Here you are defining the coefficient of the polynomial that you are defining. As we explained before, when you want to use the coefficient, then but this coefficient 0 means that you are considering the leading coefficient. And C equal 10. Again, as we explained before, C is one hyperparameter which can be adjusted in SVM. And by using C, we can find the coordinate between the complexity of the model and your flexibility for the points which are violating your separation. So then here I am using polynomial kernel, and coefficient here is 1, and here we have C equal 10. In this case, when we run this, as you can see, the model with the coefficient, the model with the polynomial kernel will be trained. For RBF, we can do again the same thing. Then here, as you can see, we are using the pipeline again. We are using the standard scaling. And then for SVM, we are considering kernel RBF, and again, C equal 10. And as we explained before, when you want to define our RBF kernel, then parameter gamma should be defined. And here, the parameter gamma that we define is 5. Yes, by changing this, you will get a different model, and you can check to see that which model works to the best. Then, as you can see, by using Python, you do not need to know a lot about math, which is behind these concepts. In another video, I tried to explain a little bit what math will be used for these models. But here, as you can see, when you use Python, then thank Python that we do not need to be worried about the mathematics which is behind this. Then here you are using the kernel, just write poly, then every other thing will be done by Python. And here when you want to use RBF, again, you just need to define a kernel as RBF, and after that gamma will be adjusted. Again, every other thing is the number of landmarks, and those math stuff that we explain, all of them will be done automatically. Then you can see that how much Python is effective. It means that you do not need to know lots of math which are behind these models. And just by defining the kernel that you want to use, you can train a model, and after that you can you can evaluate the model. So okay, then we will see more about this in homework, and hope this two example give you the idea how Python can be used on non-linearly separable datasets. Thank you.